In this lecture video, we're going to take what we've learned so far about rational expressions and equations and learn how to work with complex fractions. A complex fraction is a fraction or rational expression containing one or more fractions in its numerator or denominator. Like this example here, we have one fraction in the numerator and two fractions in the denominator. In order to simplify complex fractions such as this, it's really useful to find the least common denominator for all denominators involved. We have three denominators, 8, 3, and 12. The least common multiple for 3, 8, and 12 is 24. So that will be our least common denominator. Now let's take our complex fraction and multiply it by 24 over 24, which is simply multiplying it by 1. We will need to distribute in the numerator and in the denominator. So we have 24 times 3 plus 1 over 8 in the numerator, and 24 times 2/3 minus 5/12 in the denominator. Now when we distribute, we have 24 times 3 plus 24 times 1 over 8 divided by 24 times 2 over 3 minus 24 times 5 over 12. Notice that the result of these steps is that we've multiplied every term in the complex fraction by the least common denominator. In future examples, we may simply jump from the complex fraction to this new fraction with each term multiplied by the least common denominator, because it's the equivalent of multiplying the numerator and the denominator by the same thing, or multiplying by 1. Simplifying, we have 24 times 3, or 72, plus 24 times 1 over 8, or 24 divided by 8, which is 3. In the denominator, we have 24 times 2 over 3. Since 3 goes into 24 8 times, this becomes 8 times 2, or 16, minus 24 times 5 over 12, but 12 goes into 24 2 times, so this is simply minus 2 times 5, or negative 10. 72 plus 3 is 75, and 16 minus 10 is 6. So we have 75 divided by 6. And both the numerator and the denominator being multiples of 3, this simplifies to 25 over 2. Let's take a look at a complex fraction with a variable involved. Here in example 2, we again have a complex fraction. This time there's 3 terms in the numerator and 3 terms in the denominator, 4 fractions total. And notice that we have the variable x involved. We will once again begin by finding the least common denominator for all of the denominators. The denominators are x, x squared, x, and x squared. The least common multiple of x and x squared is simply x squared. So that's also our least common denominator. We learned in our previous example that multiplying the numerator and denominator by the least common denominator is the same thing as multiplying every single term in the complex fraction by that least common denominator. So that's what we'll do. We'll have x squared times 1 minus x squared times 13 over x minus x squared times 30 over x squared. And in the denominator, we have x squared times 1 minus x squared times 5 over x minus x squared times 14 over x squared. Now we will simplify each term. X squared times 1 is simply x squared. Looking at the second term in the numerator, we have x squared times 13 over x. With 1 copy of x in the denominator and 2 copies of x in the numerator, this simply becomes negative x times 13, or negative 13x. Next, we have negative x squared times 30 over x squared. And with an x squared in both the numerator and in the denominator, this simply becomes negative 1 times 30, or negative 30. Next, we have x squared times 1, or simply x squared, then negative x squared times 5 over x. And with 1 copy of x in the denominator canceling out with 1 copy of x in the numerator, this becomes negative x times 5, or negative 5x. And finally, with negative x squared times 14 over x squared, the x squared simplify to become a 1, and this is negative 1 times 14, or negative 14. Now we have a rational expression that we know how to simplify. We will begin by factoring the numerator and the denominator in hopes of finding a common factor. X squared minus 13x minus 30 can be factored as x minus 15 times x plus 2. X squared minus 5x minus 14 can be factored as x minus 7 times x plus 2. With a factor of x plus 2 in both the numerator and in the denominator, we simply have x minus 15 in the numerator and x minus 7 in the denominator. Let's go on to example 3. In example 3, we have a complex fraction with 2 fractions in the numerator and 2 fractions in the denominator. Notice at this time, our denominators are a mix of integers, 3 and 9, and variables, x and x squared. The least common denominator for these 4 denominators, 3, x, 9, and x squared, must include the least common multiple of 3 and 9, which is 9, and the least common multiple of x and x squared, which is x squared. So our least common denominator in this case is 9x squared. It's also what will help us clear all of our fractions at the same time. Now we'll multiply each term in this complex fraction by the least common denominator, 9x squared. First we have 9x squared times 1/3 minus 9x squared times 1 over x. In the denominator, we have 9x squared times 1 over 9 minus 9x squared times 1 over x squared. Let's take a look at each term and see what will simplify. With 9x squared times 1/3, the 9 and the 3 simplify to become 3 over 1. With the next term, 9x squared times 1 over x, the x in the denominator simplifies with 1 copy of x in the numerator. With 9x squared times 1 over 9, the 9 simplify to become 1 over 1. And with 9x squared times 1 over x squared simplifies with x squared and simply becomes a 1. Now we have 3x squared times 1, or simply 3x squared, minus 9x times 1, or simply negative 9x, divided by x squared times 1, or x squared, minus 9 times 1, or minus 9. Now let's factor the numerator and the denominator and look for any common factors. Looking at the numerator first, 3x squared and negative 9x have a greatest common factor of 3x. And factoring out a 3x leaves us with a factor of x minus 3. In the denominator, we have the difference of squares, x squared minus 9, and this factors as x plus 3 times x minus 3. Simplifying our factors of x minus 3, we are left with 3x divided by x plus 3. Now we'll head over to example 4. In example 4, we again have a complex fraction. Notice that this time we have multiple terms in each denominator of each fraction. The least common denominator for these 3 fractions needs to include a factor of x minus 4 and a factor of x plus 7. That way all 3 of our denominators are represented in our least common denominator. Now we will multiply each term by x minus 4 and x plus 7. Starting in the numerator, we have x minus 4 times x plus 7 times 6 over x minus 4, plus x minus 4 times x plus 7 times 5 over x plus 7. In the denominator, we have x minus 4 times x plus 7 times x plus 2 over x minus 4. Let's simplify each term. Starting with our first term in the numerator, notice that we have a factor of x minus 4 in both the numerator and in the denominator, so those will simplify to be a factor of 1. Looking at the second term in the numerator, we have a factor of x plus 7 in both the numerator and in the denominator, so those will also simplify to become a factor of 1. And in the denominator, we have a factor of x minus 4 in both the numerator and in the denominator, so they simplify to be a factor of 1. This leaves us with x plus 7 times 6, or 6 times x plus 7, plus x minus 4 times 5, or 5 times x minus 4, divided by x plus 7 times x plus 2. Distributing in the numerator, we have 6 times x, or 6x, and 6 times 7, or 42, plus 5 times x, or 5x, plus 5 times negative 4, or negative 20. And we'll leave the denominator factored, x plus 7 times x plus 2. Collecting our like terms in the numerator, we have 6x plus 5x, or 11x, plus 42 minus 20, or positive 22. And with the numerator having a greatest common factor of 11, this becomes 11 times x plus 2. Simplifying, we find that this complex fraction is equal to 11 divided by x plus 7. Let's head on over to our final example. In this final example, notice that we simply have one fraction in the numerator and one fraction in the denominator. So this is equivalent to dividing two rational expressions. In fact, we could simplify this using our methods from previous sections. But let's go ahead and find the least common denominator and learn how to use that method here. Let's begin by factoring each polynomial that's present in this complex fraction. X squared plus 17x plus 72 can be factored as x plus 9 times x plus 8. X squared minus 100 is the difference of squares, so that can be factored as x plus 10 times x minus 10. X squared plus 13x plus 36 can be factored as x plus 4 times x plus 9. And x squared plus x minus 90 can be factored as x plus 10 times x minus 9. Now that we have this in factored form, let's take a look at the denominators in this complex fraction and figure out the least common denominator. We have denominators of x plus 10 times x minus 10 and x plus 10 times x minus 9. Our least common denominator needs to include a factor of x plus 10, a factor of x minus 10, and a factor of x minus 9. So this is what we will multiply the numerator and the denominator by, or each individual fraction in the complex fraction. This will give us x plus 10 times x minus 10 times x minus 9 times our numerator of x plus 9 times x plus 8 divided by x plus 10 times x minus 10. In the denominator, we'll have x plus 10 times x minus 10 times x minus 9 multiplied by our original denominator, x plus 4 times x plus 9 divided by x plus 10 times x minus 9. Now let's see what we can simplify. We know that our denominators should all simplify to a factor of 1 because we multiplied by the least common denominator. Looking in the numerator, we can cancel out our factors of x plus 10 and our factors of x minus 10. In the denominator, we can cancel out our factors of x plus 10 and our factors of x minus 9. This leaves us with x minus 9 times x plus 9 times x plus 8 in the numerator, and x minus 10 times x plus 4 times x plus 9 in the denominator. Simplifying one last time and canceling out our factors of x plus 9, we are left with the rational expression of x minus 9 times x plus 8 divided by x minus 10 times x plus 4. And that complex fraction has been simplified. Remember, you can also go back to our previous methods for dividing rational expressions and simplify that way as well. You'll still end up with the same answer. That will conclude this lecture video on how to simplify complex fractions.